All right, let's dive right into this explainer. July 9th, it's honestly one of the most extraordinary dates in the entire history of math. And following the structure in our ENG source document today, we're going to see exactly why. I mean, on this one single date, across different centuries and different countries, completely brilliant minds literally changed the modern world we live in. So let's meet them, one by one.
Because on this one date, so many wild stories intersect. We're essentially going to embark on a high-speed detective story today to track down these incredible people. And we're going to start with our very first mystery.
Think about it. We use these apps every single day, right? But have you ever actually stopped to wonder how Google Translate works? Like, how does a literal machine learn to understand and speak our language?
Well, that brings us to Kathleen Booth, born on July 9th, 1922.
The answer to that first mystery actually goes all the way back to her groundbreaking work at Birkbeck College. What she did was she created a way to translate complex human logic into a really simple code that early computers could actually understand and execute. She literally wrote the very first assembly language. And because of that, she was able to direct the world's first public demonstration of a computer translating text. And get this, that was all the way back in 1955. Insane, right?
And this brilliantly illustrates our big takeaway here. Every single translation app you use today owes a massive debt to her very first computer code.
Okay, so we're still on July 9th, but now we're going to jump exactly 10 years backward in time. Same exact date, but a totally different, yet equally brilliant mind.
Let me ask you this. Have you ever wondered if there's a perfect, hidden pattern tucked away inside what just looks like an infinite, chaotic mess of random data?
This leads us right to David Champernowne, born on July 9th, 1912.
So our answer here starts with something called Champernowne's constant. It's what mathematicians call a normal number, and he made it in the most straightforward way possible. He just took our everyday natural numbers, 1, 2, 3, 4, 5, and so on, and he strung them all together right after a decimal point to create this one massive, literally never-ending number. But the crazy part? He proved mathematically that every single digit occurs equally in this infinite sequence. He basically brought perfect balance to a totally endless stream of data.
He essentially found perfect order, just hiding in plain sight, right within an endless string of numbers.
All right, same date, but now we're jumping to a completely different era and a much, much bigger physical scale. Let's move to our next timeline jump and see how this whole thing builds.
We completely take flight for granted nowadays. But have you ever wondered how we actually know, for sure, that a massive, heavy metal tube is going to stay safely up in the air while flying at hundreds of miles per hour?
That brings us to Beatrice Mabel Cave-Browne-Cave, who passed away on July 9th, 1947.
The answer to the airplane mystery lies with her early work calculating complex ballistics trajectories during World War I. Now, what's really fascinating here is how she took that knowledge and did the intense, groundbreaking math for the Air Ministry. Math that was absolutely required to guarantee aircraft stability. She calculated the incredibly complex forces on airplane tailplanes, and she researched exactly how objects move through viscous fluids, like air and liquids. She essentially mapped out the invisible forces of flight using pure mathematics.
So literally, every single time you fly safely, you are being supported by her calculations of the invisible air.
One single date. So many incredible stories. Let's keep this moving to our fourth and final mathematician.
In a world where we literally rely on computers for everything, our money, our hospitals, our safety, how do we double-check that the math running those computers is absolutely 100% perfect?
We find that answer with Nicolaas de Bruijn, born on July 9th, 1918. So he created this formal language called automath back in 1968, and it was designed strictly for mathematics. It basically allowed computers to read human math and automatically verify if a proof was logically flawless. So the real game changer here is that he built a way for machines to double-check human logic, and that laid the absolute foundation for the modern, secure software we all rely on today.
He literally taught computers how to become the ultimate referees of human logic.
Now, just look at how beautifully this date ties everything together across history. I mean, what actually connects an early computer scientist, an economist, an aviation pioneer, and a logic expert?
The pattern in chaos. One date, 4 stories.
Whether it was Kathleen Booth giving logic a digital language, David Champernowne finding predictable patterns in infinity, Beatrice Cave-Browne-Cave mapping the invisible air to keep planes stable, or Nicolaas de Bruijn teaching machines how to verify our own truths, they all looked at a chaotic, messy world and asked how to find the mathematical pattern hiding inside of it. And guys, because they asked those questions, our world today has seamless language translation, safe aviation, and totally secure software.
The math we use every single day just surrounds us, waiting to be understood. So I'll leave you with this. What pattern will you find